Welcome back to Algebra 2, everybody. We are going to start Unit 3 today. And Unit 3, Lessons 1 and 2, are going to be a review for hopefully most of you. These two lessons really go over all of the exponent rules that you have learned in past math courses. You can see on your screen here, these are all of the rules that you should know from your past math courses. I want to call your attention to a couple of them here. First things first, I want to call your attention to number 7, which is the square roots rule. You should know how to take a square root of a number. For example, here, when we have the square root of 9, what we're really asking is what number multiplied by itself is equal to 9. And we know that when we take the square root of 9, it could be positive or negative, plus or minus 3. The one that you may have forgotten is cube roots. Cube roots is the same concept as square roots. The only difference is the cube root is what number multiplied by itself 3 times is that number. So the example I gave here is the cube root of 27. So what number multiplied by itself 3 times? In other words, what number cubed equals 27? And in this case, the cube root of 27 we would say is 3, because 3 times 3 times 3 is equal to 27. Just like we would say that the square root of 9 is plus and minus 3, because 3 times 3 is 9, and negative 3 times negative 3 is also 9. The big difference between square roots and cube roots is that with cube roots, we do not need to do the plus minus thing, okay? 3 times 3 times 3 is equal to 27, but if I do negative 3 times negative 3 times negative 3, I do not get 27, I get negative 27. So in this case, with cube roots, you do not need to do plus, positive, and negative, plus and minus. The other big difference with cube roots is that you can cube root a negative number, okay? You can't square root a negative number because it's impossible in the real number system to square a number and have the answer be negative. But you can cube a number and have the answer be negative. The example I gave was negative 3. Negative 3 cubed, negative 3 times negative 3 times negative 3 is equal to negative 27. So the cubed root of negative 27 would be negative 3, just like the cube root of 27 is equal to 3. With that in mind, let's take a look at the examples here. So 1 through 5, find the value of each variable that makes the equation true. So with number 1, okay, when we're multiplying with exponents, we add the exponents. So 2 cubed times 2 to the 5th, when we're multiplying, we add the exponents. So this would be equal to 2 to the power of 8. So 2 cubed times 2 to the power of 5 would be equal to 2 to the power of 8. So on number 1, we will say that A is equal to 8. Simple as that. Same thing on number 2. When we're multiplying, we add the exponents. So what number plus 7 is going to be equal to 11? It's going to be 3 to the 4th. 3 to the 4th times 3 to the 7th is equal to 3 to the 11th. Again, multiplying, add the exponents. So B in this case is going to be equal to 4. Number 3, 4 cubed divided by 4 squared. So now we're dividing instead of multiplying. So when we're multiplying, we add the exponents. So when we divide, we're going to do the opposite. We're going to subtract the exponents. So 4 cubed divided by 4 squared is going to be equal to 4 to the power of 1, because 3 minus 2 is equal to 1. So in number 3, we will say that C is equal to 1. Number 4, same thing. We are dividing, so we have to subtract the exponents. So I have to write it so that 8 minus what is equal to 2. 8 minus what is equal to 2. And of course, that's going to be 6. So it should read 5 to the power of 8 divided by 5 to the power of 6 equals 5 squared, because 8 minus 6 is 2. So on number 4, we will say that D is equal to 6. Number 5, this is raising a power to a power. All right. In your lesson notes, when we have a power raised to a power, we multiply the exponents. So in this case, these two exponents should multiply to get 20. So what number times 4 is equal to 20 is what we're really asking ourselves. What number times 4 is equal to 20? And of course, we know that the answer is 5. So number 5 should read something like this. So 7 to the power of 5 to the power of 4 equals 7 to the power of 20. So on number 5, we would say that N is equal to 5. So 1 through 5 are a review of the basic exponent rules. 6 and 7 have to do with square roots and cube roots, which I talked about earlier. So for each of the following, without using a calculator, estimate the answer by determining what two whole numbers it is between. So number 6, we are estimating the square root of 33. The square root of 33, we should know, is not a perfect square. There is no whole number that I can square it and get an answer of 33. If I take the square root of 33 on a calculator, I'm going to get a decimal. So we can't get an exact answer without a calculator, but we can estimate, like it says here. Okay, and the way I can estimate this is because I know, for example, I know that the square root of 25 is 5, right? And I know that the square root of 36 is 6, right? And last time I checked, 33 is between 25 and 36. So to estimate, I'm going to look at a perfect square that is larger than 33 and a perfect square that is smaller than 33. So I know that the square root of 25 is 5, and I know that the square root of 36 is 6. 33 is between 25 and 36. So the square root of 33 is therefore going to be between 5 and 6. So let me explain that one more time. Because 33 is between 25 and 36, and I know that 25 and 36 are perfect squares, then the square root of 33 is going to be between 5 and 6. I know it's a decimal value, and I know it's going to be somewhere between 5 and 6. So the square root of 33 is between 5 and 6. That answers the question. Estimate the answer by determining what two whole numbers it is between. The square root of 33 is between 5 and 6. So number 7, we're going to do the same thing, except now we're going to estimate the cube root of 4. So we're going to look for a perfect cube that is close to 4, the one that is lower than 4 and one that is higher than 4. So we should know already that, for example, the cube root of 1 is 1. Why? Because 1 cubed is 1. And we should know that the cube root of 8 is 2. Why is the cube root of 8 equal to 2? Because 2 cubed, 2 times 2 times 2, is equal to 8. So I know that the cube root of 1 and the cube root of 8 are perfect cubes. And just like with before, 4 is between 1 and 8. So 4 is between these two. So therefore, the cube root of 4 has to be between 1 and 2. So the cube root of 4 is going to be somewhere between 1 and 2. That is how we estimate square roots and cube roots without actually using a calculator. And that is it for lessons 1 and 2.